Hello guys, so welcome to the first topic of this channel. So the first topic I'm going to go through is transformation. I like to discuss these four topics together usually. Okay, transformation, graph, functions, and inequality. Okay, so I like to lump different like differentiation, integration, application of differentiation, definite integral, and Maclaurin series. Okay, I like to lump five of them together, lah, etc. Okay, so next time I will cover more about the rest, and today we will just focus on transformation. Okay, so personally, right, I feel that the call about transformation, right? Okay, look at it this way. Usually, when you are being taught transformation, right, you are given the description, then after that, you are given the most basic form of expression. Okay, so for example, you guys are given this y equals to x. Okay, after that y equals to 2x. Okay, then explain how it changed, etc. Okay, so I try to explain it in another manner um, so that there's truly a fundamental, uh, fundamentally rigorous uh, explanation. Yeah, like you can convince yourself instead of just like digesting it, instead of just like memorizing the scenario. Okay, I want it to make sense to you guys. Okay, so how I teach it, right, is if we see the end result, right? Okay, it's always about shifting the graph like this, okay, or shifting the graph like this, or stretching the graph or compressing the graph like this and like this. Okay, so based on those four scenarios, right, and even reflection as well, so six scenario, right? Um, I can generalize it to say that right, transformation is all about keeping keeping x value the same and change the y value, or changing y value while keeping the same x value. Okay, so I will discuss based on that perspective. Okay, very important. Try to relate what I just said, right, to what I'm going to show you. Okay, so let's say we have a more advanced example, slightly more advanced lah. Okay, so 2 plus 7 plus 10. Okay, so coming from just now that example, right, student would think that, oh, it's just shifting by 3 lah. Okay, but it is not lah. Okay, so just now, right, I was trying to tell you this concept of same y value, different x, or the other way around, depending on is it y-axis and translation about y-axis or x-axis. Okay, so let's say, right, if I rewrite this thing, right, as something like this, okay, and this is equivalent to this thing. Okay, so they are similar in certain manner lah. Okay, and as long as I make the value in the boxes the same, okay, the y value is going to be the same. Okay, so for a different value of x, same y value. Understand? That is where same y value, x now is shifted. That's why it's a translation. Okay, so for example, okay, let's say, right, here is a 1. Okay, to make this whole y value the same, in the first place, I need to make this whole box the same. Okay, so I need to, but then I also need to make sure that, right, this expression, right, is the same as above, right? else is different expression, then what's the transformation, right? Okay, so to make this the same as the above, right, you need to be x plus 1.5 so that overall it can be plus 10. Okay, so how to make this whole thing into 1? Okay, the x need to change to 0.5 so that eventually the whole thing become 1. Okay, so you understand when the whole box become the same value, right, the y will be the same value. Okay, and that is okay, so although the box is the same value, right, okay, note that your x is different. Okay, let's try another example. Okay, if this one is a 2, okay, this thing need to be a 0.5, right, so that uh, this thing need to be a 0.5, right, so that eventually it make the whole thing into 2. Okay, so look at how your x value changes. Okay, from 1 to negative 0.5, from 2 to 0.5. Okay, as a result, right, 1 to negative 0.5. Okay, so you are shifting it by, okay, so their difference is minus 1.5. Okay, minus 1.5. Okay, so initially the position is 1. Now the position is negative 0.5. Okay, initially the position is 2. Okay, now the x position is 0.5. Okay, so that is a shift of 1.5 units in the negative x-axis direction. Understand? Okay, because this one original value original value, now the new coordinates coordinates means new x and y okay, means this one new x and y is the same value. That's why it's shifting horizontally. Okay, that's why we call it a translation of 1.5 units in the negative x-axis direction. Okay, so if you think of it from the graph, okay, it's gonna look something like this. Okay, so your knowledge, your graph need to be very strong throughout your whole high school or JC years lah. Okay, because it's interrelated to a lot of other topics lah. Okay, so 2x plus 7, right, your graph gonna look like this. Okay, and then yeah, so initially, right, okay, the position, right, okay, is 1. Okay, then after that it shift by negative 0.5. Okay, so say this is not the best drawing. Okay, so negative sorry, shift by negative 1.5, right, so maybe around here. Okay, negative 0.5. Okay, then it should still have the same y value. Okay, so you see same y value, right, but the x shifted. Okay, so 2,9 and negative 0.5, 9. Okay, so yeah, that's it. So it shift by negative 1.5. Okay, how I know this is 9, right? I don't really care. Okay, I know that like this whole thing is gonna get me 1. Okay, so that's why I keep saying you need to get your box to the same value, then your y will take care of itself. Okay, and of course, if you want to substitute in and do your due diligence to check, it's all right as well lah. Okay, but then it kind of shows that you don't really understand that concept that I was trying to drive at. Okay, so now that we finished translation, okay, we will cover scaling. Okay, So mm, okay, I want to do something different, okay, to help you to understand what really is equation better. Okay, so this right is equivalent to half y equals to x. Okay, when I say, listen very carefully, this is important. When I say two equations they are equal, right, what I really mean, right, is that their pairs of coordinates or their combination of different coordinates is the same. Okay, so for example, if your x is 1, here y will be 2, x is 2, y will be 4. Okay, if your x is 1, to make this whole thing 1, your y need to be 2. If your x is 2, to make this whole thing 2, your y need to be 4. Okay, so x is 2, y is 4. Okay, so all the set of possible combination of your x and y, right, is the same. That's why that equation is the same. That's why their graph is the same. That's why they are the same. Okay. Okay. So yeah, I actually want to show you scaling with respect to y lah. Okay. So over here, right, it's about making this whole making the x the same. Okay, just now we make y the same. Now we want to make x the same. Okay, so as long as right we make this whole box the same value, right? Okay, your x is gonna get the same value. Okay, but your y in each individual case are different. Okay, so get the idea? Same x, different y. Okay, same x, different y. Okay, so over here, let's say, right, is 1, right? This y need to be 2. Okay, when it's 2, okay, this thing need to be 4. Okay, so if you imagine from the coordinate perspective, okay, yeah, it is, I already said already, the x value is going to be the same. Okay, so this one, then it become like that. Okay, so look at how the y value changes. Okay, you realize that for the same x value, the y is always multiplying by 2. Okay, so that kind of tells you that, right? For the same x value, the y is gonna increase by 2 times. Okay, increase by 2 times. Okay, so do note very carefully how you should really plot it is this value, okay, then twice of it, so it's around here. Okay, this value twice of it is around here. Okay, so this value twice of it still 0. Okay, so that is going to be your new graph. Okay, like twice of it. Okay, so you get me. Okay, so so this one, right? Okay, whenever you write those words, right, it really literally describe what you see. Okay, so over here, right, is a scaling with factor 2. Okay, then parallel to x-axis. Sorry, parallel to y-axis. Okay, um, yeah. Okay, so I gonna go back a bit. There's something very important that I forgot to discuss. Okay, so over here, right? Okay, when we are talking about transformation, right, one determine uh, graphically, right, your description, right, it has a lot to do with this thing, replacing, okay, x with x equals to, sorry, x equals to x plus 1.5, okay. So when, the key point of doing this, right, is really to make the rest of the expression the same. To make, here will be 2, 7, here will be 2, 7. Okay, as long as you make this equal, right, the y will be the same. Okay, so what I'm trying to say, right, is you need to arrive at this, what you are trying to replace, so that you know how to describe your transformation. Okay, understand, right? Because transformation is about fixing that y and changing that x. Okay, and that changing of x, fixing of y comes from here. Okay, change, fixing of y comes from here. Changing of x comes from here. Okay, that's why you need to do this step. Okay, cannot run away on. Okay, so we have seen that, okay, this in this case is replacing x with x plus 1.5. How about in another scenario? Okay, here is about replacing y with half y. Okay, so it will be a scaling of factor 2 with parallel to x-axis, okay, parallel to y-axis. Okay, so do note that, right, whether is it y-axis or x-axis, right, okay, all these things, right, this y, right, okay, this y, okay, or this x, right, it's just arbitrary, okay, means that they can be apple, can be orange, can be Y, can be Z. Okay, so if we describe this thing as scaling da 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 da, right? Okay, we can, because it is arbitrary, okay, if we change x to half x, right? Okay, you just it's just gonna be scaling with factor 2 parallel to x-axis. That's it. Okay, and but the thing you need to know that when you are doing this, make sure that you are replacing what with what. Okay, so don't get, it's strictly replacing. Okay, it's not times 2 by the left hand side or times 2 by the right hand side. Because I know that in secondary school we are we process information like this. That's why I keep saying that it's very one directional. Like sometimes you think that um not one direction. When I say one directional, I mean very systematic. Okay, so sometimes you think that when this condition the result should be like this, then the other condition is not like that. Then after that, you start to doubt yourself. You start to get confused. Okay, so I want you to re-explore different ways of digesting information. Okay, okay. So the last example. Okay, so over here, right, the last example is, I cannot think of an expression now, so I just gonna do the typical FX example. Okay, so let's say, right, my graph is like this. Okay, so this is y equals to fx. Okay, changing y equals to fx to y equals to f mod x, right? Okay, you kind of again, it's always relying on that principle, like different x, same y. different y same x. Okay, so over here, right? Okay, I don't know whether intuitively you thought of that, but then like 1 and negative 1, right, is gonna give you the same y value. Okay, then likewise, right, this thing, uh, negative 2 and 2, right, is gonna give you the same value. Okay, so let's process this part first. Okay, so this part, okay, over here, okay, is nothing different from your F1. Okay, is nothing different from your F2. Okay, so that's why, like for graph question, you cannot mix out your x and y. Later, I will give you more example. No, I will point it out when we are dealing with the negatives. Okay, then it will be more obvious. Okay, but you need to be very clear with your x and y. Okay, so now, right, when the value of x is 1, okay, what is the y value? Okay, that y value, right, is f1. Okay, so we need to take from here. Okay, so we need to take from here. Okay, so the value is here. Okay, then f2, the value is here. F3, the value is here. Okay, cannot when x equals to 2, x equals to 3. Okay, so your x, right, is strictly dependent on here and here, strictly. Okay, okay. Now, right, let's look at the negative part. Okay, I know that the mod is gonna be a bit confusing. Okay, so this one, right, is equals to f bracket 1. Okay, this is a y value. Okay, and because there is a lot of brackets and functions, there's a high chance you mix up what's your objective. Okay, your x here, right, okay, is negative 1. Okay, it's not 1, it's negative 1. This one is after we process the modulus, it becomes a positive 1. Okay, but don't confuse your x to be negative 1 with your x to be equal to 1. Different. Okay, so when your x is negative 1, right, it's going to take the value of f1. Okay, f1 is a value. Okay, so when this one is negative 1, what is that f1 value? Okay, f1 value is a y value, so it represents this amount. Okay, that's why your y is here, and minus 2, minus 3. Okay, so this will be your graph. Okay, so yeah. Okay, maybe I should try the mod y with you guys as well. Okay, so now let's say, right, okay, coming to here, right, I'm going to mod my y. Okay, okay, so over here, okay, you see, your uh, y is negative, be negative 1 or 1, right? Okay, it's gone on negative 2 or 2, right? Okay, it will eventually be 1 and 2. Okay, so it's gonna be, they're gonna share the same x value. Okay, but their y is different. Okay, so yeah, for example, right, okay, let's say, because all these got pairs of coordinates. Okay, so let's say, right, here is 1 comma 2. Okay, then here 2 comma 3, here 3 comma 4. Example. Okay, so this one, when this one is 1, this one is 2. Okay, so the relationship that relates them is 2 equals to f1. Okay, so if I put a negative 2 here, right, Okay, negative 2 equals to 2. So 2 equals to F1. Okay, so in the first example, right, the x and y coordinate, right, is 1 comma 2. The second example is 1 comma negative 2. Okay, so that's what I mean by every x, right, there will be two y value correspond. Okay, so for example, negative 1 and 1, negative 2 and 2. Okay, can okay, so let's say, right, your okay, initially, right, this one is say example 1. Okay, and this one is 2. Okay, so you substitute 1 inside, then 2 inside. Okay, so your x value, your x value is 1, your y value is 2. Okay, so it's going to get this point. Okay, now after that, you substitute your x value equals to uh, negative something. Okay, say example like that, right? Okay, then after that, your say your y value, right, initially, right, is 1.5. Okay, so initially it's like that, right? Okay, this mod x like that, your x and y value pair, right, is gonna be the same pair. Okay, just looking at y and x. Okay, because of this, right, we know, because of this previous expression equation, right, we know that this equation is still valid. Okay, because we know that this equation is valid, it will make the new coordinates. Okay, please bear with me, I know a bit confusing. Okay, so over here, right, when it's negative 1, is negative 1.5. Okay, so your graph gonna look something like this. Okay, so now, right, it's not just 1.5 that satisfies this equation. Okay, it's negative 1.5 that's also satisfies this equation. Okay, understand? Okay, because of this equation previously. Okay, that's why this thing is gonna satisfy it also. Okay, that's why every x value, there is two y value of positive and negative. Okay, so to play back this video, if you are not sure lah. Okay, so how I plot this, right, is like visually um I will have a distance in between, distance in between, distance in between, and I make sure I follow that distance lah. Okay, so yeah, that will be your modulus of y kind of graph. Okay, I think the part that students get very confused, right, is this part lah. Okay, this part. I don't know whether you grasp what what I was trying to say. Okay, but then let's say x plus 1 over x plus 2, okay, equals to y. Okay, so there's a very specific combination, right, that satisfies this equation. Okay, that specific combination, right, for example, right, is 1 comma 1 comma 2 over 3. Okay, cannot. Okay, so now my new expression is like this, right? Okay, so that specific combination, right, should still be 1 and 2 over 3. Okay, or it can be 1 and minus 2 over 3. Okay, so yeah, that's it for today. Take the main idea, okay, understand 70% or 65%, okay. After that, try to reproduce on your own. You don't have to keep on replaying this video and then catch every words I say. Get the main concept, execute it. Okay, so I know my voice is very muffled. Yeah, so do check out the subtitles if you need any help with the with my pronunciation. Okay, so that's all for today. Bye bye.